handling lifecycle events, maintaining view state, and persisting data. These are all problems that have been around basically since the beginning of Android development. Common challenges that we've all worked on at one time or another, no matter when we started as an Android developer. And it's also these same challenges that have given rise to the popularity of things like clean architecture in the Android community, and more recently with the release of the Architecture Components library by Google. And so what I want to do today is take a little bit of a historical approach to the topic of clean architecture, look at it in the context of classic software development principles and how we can best apply those to modern Android development. And we're also going to approach this from the angle of saying that we already have somewhat of a, when it comes to the new Architecture Components library, assuming we already have some sort of clean app design in place, how can we best take advantage of these new tools to improve our existing design? So my name's Chuck, and I lead the Android team at Button. For those of you who aren't familiar with Button, we build a set of mobile SDKs for Android, iOS, and mobile web that allows you to place apps and services inside of your application so that users can do things like make a purchase or book an Uber or book a hotel on hotels.com. And the best part is that you as the publisher then gets a commission for that transaction. And finally, as you can imagine, this type of project involves a lot of unique challenges as our products get used by millions of users all over the world. And so if that's something that sounds interesting to you, come talk to me afterwards, because of course we're hiring. So let's dive in and have some fun. Clean architecture is one of those things where, you know, a lot of times we start out as developers with the best intentions, but over time, as things like deadlines and scope creep come into the picture, we don't always get to stick with the original plan we had in place. And so what might start out as a well laid out application with the best of ideas and goals about how we're going to organize it, eventually might wind up looking something like this. Or something like this. And unfortunately, over time, if without proper care and maintenance, your code base might start to look like this. When in reality, what we want to build is something that looks like this. Or like this. Or even like this. You know, this picture in particular reminds me of an interview that I heard on NPR not too long ago with an author who was doing a worldwide book tour, and his publicist went ahead of time to Japan to make all the accommodations and arrangements for their stop. And when the author arrived, the publicist brought him to a place that looked much like this, and he walked in and it was this pristine room, impeccable, almost completely empty, except for on one wall there was a table and a vase with the most beautiful arrangement, bouquet of flowers he had ever seen in his life. And he was just completely blown away. He's looking around and he turns to the publicist and he's like, I don't understand, what is this? And the publicist responds, this is elegance. And so if we take that same idea and apply it to software, I think this quote sums it up really well. Elegance in design is a lack of unnecessary complexity. And so when we're thinking about clean architecture, and for those of you who were in the previous talk with Yeet and Israel, you're going to notice a lot of common threads here. And one thing that makes me really happy as an Android developer, having done this since 2009, is we're at a point now in the history of, as a community, where the ecosystem has evolved and matured to the point where these are the things that we're thinking about as developers. It's not just about how to get something up and running as quickly as possible. And so really, when we're talking about clean architecture, what are the advantages? What are the goals for us as developers? What are we trying to accomplish with this? And so for me, it really breaks down into three categories. We have the idea of separation of concerns, and this really speaks to building layers into your application. The second one is state synchronization. So if you're going to have multiple layers to your application, you want to make sure that the state is synchronized across each one. The screen, the session, and your server state are all in coordination with each other. And finally, the topic of testability is naturally part of the conversation when it comes to clean architecture, because one of the primary goals is with separated components, it becomes easier to test each one. So going back in history a little bit, in the 1960s and 1970s, software systems really didn't have the same concept of a graphical user interface or a GUI like we have today. And then so in the 80s and 90s, as more visual interfaces began to become commonplace, so did a whole new host of problems for developers. How do you handle dynamic user input? How do you keep the view state in sync with the underlying application? And how can you best separate your presentation logic from your domain logic? And I think it's important to recognize these aren't new concepts in software development. For those of you who've never read this classic series of articles by Martin Fowler, this is from the mid-2000s, and it talks about a lot of the same ideas that we're trying to figure out in the Android community today. Things like separated presentation and how to lay out your code base in order to keep the logic and the data and the view all as their own discrete components. And so, like I said, the fact that this is coming into the forefront and becoming more popular in Android development, I think is a good sign of the maturity of the ecosystem. And so what I want to look at today is what lessons can we learn from these classic software design principles, and how can we best apply them to modern Android applications. So first, let's talk about separation of concerns. And as I mentioned, this really speaks to the idea of a layered application. You have your view layer, you have your presentation layer, and then you have your domain layer. And specifically, when we're talking about it in the context of Android, one of the ideas here is we want to keep our Android dependencies encapsulated inside of the view layer. And this way, it keeps our presentation and our data and our domain logic Android-free, which has benefits for testability. Another way to think about this is the idea of treating the framework as a plug-in to your application. When you approach building a new app, one way to think about it is, I'm building an app that does this or that, but the fact that it's an Android app is almost a side note. And we integrate the framework as sparingly as possible and only at the layers where it needs visibility into the rest of the code base. This also gives you maintainability over time, so as your different layers evolve, ideally a change in the presentation model or in your domain model is not going to require a change in any other layer in the application. Same thing goes for the view model. And so you have the ability to evolve each component isolated and independent of the rest of the app. State synchronization. The idea here is mainly that you have three different states of the data, or three states of the data that exists in your app at any one time. You have what's currently displayed on the screen to the user, you have what is in memory in your application, and then you have what is stored on your server. Now, this talk is primarily going to focus on the synchronization between screen state and session state. There's a whole another realm of ideas that we could get into when we think about synchronizing with a remote data source. But primarily what we're going to focus on here is making sure that what is shown on the screen is consistent with what the underlying state is in your client-side app. Now, you might think of the server or the session as the source of truth for what your data is at any one time, but I can guarantee you the user has a different viewpoint, and that is what is currently displayed on the screen is the source of truth for them. And so when it comes to testability, I have a confession to make. Really, every talk I give is just a Trojan horse for an opportunity to talk about testing. So you've been warned. The Android framework being encapsulated in the view layer does a lot as far as making the rest of your application more testable, because then you can run pure JUnit tests for your presentation and your domain. You don't have to worry about incorporating Android dependencies. It runs much faster than things like Espresso or Roboelectric. But then when it comes to whatever's left over that you can't possibly pull out of the Android components, that's what these tools are there for. Many of you are probably familiar with the test pyramid from Mike Cohn's 2009 book, Succeeding with Agile. And there's a few ideas expressed in this visualization here. One is that you should have, by and large, most of your tests should be unit tests, low-level tests that test one thing and test it in isolation, that run fast, are very repeatable, very reliable. One step up from there is your service or integration layer tests, which tests how multiple components interact with each other without necessarily having to run your full system from end to end. And then finally, for those things that can only be tested through the UI, you have your UI layer tests. Now, also represented here is the idea that as you move up the pyramid, your tests become slower and they become more expensive and somewhat difficult to maintain. And so that's why we want to favor towards the low-level tests and use the higher-level tests only for those things that are difficult to get into the unit test harness, like the Android framework. And so I have my own version of this based on the original idea, which kind of expresses where I think the tools that we have available to us today fit into the traditional idea of the test pyramid. And that is your low-level tests are going to rely on JUnit and Machino. They're going to run in the local JVM. They're going to run fast. And they're going to be easily repeatable, especially if you want to do something like test-driven development, if you like self-torture as much as I do. One step up from there is our integration level tests. Now, this is a piece that sometimes gets left out, but for example, if you're working on a library or an app that is tightly coupled to the Android framework, say, I don't know, location-based, for example, those things are going to be difficult to test with just pure JUnit. And so I like Roboelectric. I think it slots in well here as a bridge between full-on end-to-end UI-driven tests and what we have available with the low-level JUnit tests. And so what it does is it allows you to still run in the local JVM against real Android jars, stubbing out any system-level dependencies, but you get to see a very realistic simulation of how your code interacts with the framework. And then finally, at the highest level, we have UI tests, which can be driven by Espresso or UI Automator. And this actually requires building your full application and a test application, compiling them, dexing them, installing them on an emulator or device. You can see why this becomes the most expensive and the least repeatable of all our options for testing, but also becomes the most realistic. So I'm sure you've heard of these different UI architectures that have been thrown around, and folks have tried to apply them in different ways to Android. And they might start to all seem the same after a while, but really there are some subtle differences in the role of each component and actually the way that the information flows throughout the app. And so I want to take a look at that real quick. And I think in doing so, it's useful to use the idea of a case study or a working example as the backdrop. And so we're going to look at the case study of a login application. Any Phineas and Ferb fans out there? Yeah? Okay, good. So this simple app is actually based on the template that you get with Android Studio when you say, I want to start a new project and I want it to be login based. This is the app that it spins up for you. And so what we're going to do is take a look at how we might apply the idea of a few of these different architectures to a login activity. So the first one I want to talk about is supervising controller, or what is probably most commonly referred to as MVC. And so the pattern MVC, or the architecture of MVC, first became popular with Smalltalk in the 80s, and then went on to become the basis for some of the ideas behind Objective-C and iOS. That's another talk for another event. But really, for me, what I think characterizes classic MVC is the idea of a one-way flow of information. So your controller handles, the view simply listens for user input and then passes that on to the controller. The controller then performs some input validation and figures out how to package up that data and make it useful to the domain model. Now, what really sets MVC apart from a lot of the other architectures that we're going to look at is the way that the view has this direct dependency on the model, and it can use some form of an observer pattern, or I think what slots into this really well with Android is the idea of data binding. And so using expressions actually in your XML layouts with data binding, you can bind your views directly to your model so that any change in the underlying state is then reflected in the display. The next one I want to talk about is called passive view, or otherwise commonly known as MVP, Model View Presenter. This pattern is also sometimes referred to as humble view because really the primary goal here is to get as much logic out of the view as you can. And you'll notice here that there is no dependency this time between the view and the model. So we have a bidirectional flow of the information, different from MVC where it was a one-directional flow of information. And the presenter essentially acts as an intermediary between your model and your view. Now, we don't want the presenter having a direct dependency on the concrete class of the view, whether it be an activity, a fragment, some sort of layout or compound view. So it interacts through an interface, but it's more of a push of information. It's less of an observation and more of like the presenter saying, hey, view, show this now. And so it's a little bit of a different idea in the way that it flows. And so I like to refer to this state synchronization strategy as flow synchronization. And this also has implications for how that we approach testing. Since we have this interface now and we have a presenter pushing code to it, we're going to need to replace our view with some sort of stub implementation in the test environment. The third and the last kind of classical pattern I want to talk about here is presentation model, also commonly known as model view model. Now this is similar to what we saw with the other two, except they're, again, similar to MVP. There's no direct connection between the view and the model, no direct dependency that they know about each other. The view model acts as a sort of intermediary, but it's more of a pull or observer flow of information as opposed to the view model pushing the state updates back to your view. So a subtle difference in the dynamic of how the information flows throughout the app. And so essentially your view maintains two connections on the view model, one to push user input and events, like a click of the login button, and then another one to observe changes to the session state that is stored in the view model itself. So as you can see, there's like subtle differences to the way that these patterns play out, and really which one is best to use is up to your individual application. When you ask me which one I prefer, I lean in the direction of the humble view, otherwise known as model view presenter. And like I said, every talk is just a Trojan horse to talk about testing, and that's where I think MVP really shines. Because passive view or humble view is the only one that actually gets all of your synchronization code out of the view and into pure Java classes. Whereas with data binding, you have expressions embedded in your XML that then are linked to your model. Good luck testing those in a way that's going to run fast on your local machine. And with ViewModel, you have to maintain all of your observer code in the view as well. If you actually want to get that into a unit test environment, it's best to push that all out into a presenter. And so for simpler apps, MVC or MVVM straight up might satisfy all the needs that you have. But for more complex applications that involve in-depth presentation logic and multiple sources of data, I always prefer model view presenter as my personal choice. And so let's expand on that a little bit and how we might apply that to the login situation in the Android context. So a lot of times when I see people implement model view presenter, they'll take an interface and call it the view and put that in front of the activity. But I think this is problematic for two reasons. One being that the activity has a lot of responsibilities. Not only is it, the controller of your UI, but it is also listening for user input. It's handling lifecycle events coming in from the system. It's, by nature of being a context, it's also your gateway to system services. And so I think it's helpful to actually think of your view as a separate piece from the activity. And so if we break it down like this, the view becomes a member of the activity, whether you want to use a compound view or some type of custom layout. The ability to reason and abstract that out from the rest of what's happening in the activity, I think, is really useful. Well, now we have a different problem. It's the overloading of the term view. So we have an interface for our activity called view, but we also have our components, which are views. And so what do we call that interface to disambiguate? Well, I actually like calling it a controller. I think this works well because this is the interface that controls what's happening in the UI. And really, when it comes down to it, these are just names that allow us to reason about and communicate what our intention is as a developer through the code we write, and also when we have conversations and collaborate with other developers. And so you might be thinking, wait a minute, well, is this MVP or is it MVC? You can't have both. Well, it's okay. You can have both. And really the question is, what is the role of each thing in the context of the architecture you're implementing? And actually this is even alluded to in the documentation for the new architecture components. If you read up about the ViewModel component, it talks about pushing data back to your UI controllers, namely activities and fragments. And so I think it's a natural name for the role that it plays when you have this sort of architecture. So let's look at a little bit of code for how this might be implemented. So this is a pretty stripped down example of what the login activity might look like if you're using MVP. and have an interface in front of your activity called login controller. And you see there's nothing crazy happening here. We're simply binding a click listener to the login button and then forwarding that event to the presenter along with the contents of the email and the password fields. So not a whole lot happening in here, very humble, very passive view, not really a lot of logic to worry about testing. And then the same way that I was talking about, it's useful to separate the idea of your view from your activity. One way to do this is through compound views or custom views that wrap up multiple views so that the activity itself actually has a very simple layout file. And you can see here the login views are really just a collection. The login view is just a collection of the 2 input text fields as well as a field to display an error. And then it also contains the button itself that triggers the event. So there's no magic in here, no data binding expressions with hidden logic that's untestable. Well, then when we get to, okay, so here's the login activity again. So we see when there's a click on the button, it forwards that to the presenter. The presenter is then actually where the presentation logic happens, like things like performing input validation. Dissecting the raw input that comes from the user, parsing it out, updating any error fields appropriately, and eventually once it decides that it has valid input, it sends that into the domain layer where your pure business logic that doesn't care anything about how it's being displayed to the user resides, namely how to authenticate the credentials that you've received against some source of truth. So then when it comes in order to somehow communicate that result, synchronize that session state back to the screen, this is where the controller interface comes into play. This is what our activity implements, and this is all the presenter sees of our activity. It says, well, either we're going to show a user as the end result of this click, or we're going to show an error, one or the other. And it doesn't care how that happens. So our login activity then, by nature of implementing the controller interface, knows how to show that user or how to show that error on the screen. And again, we have a user view that wraps up the actual fields that are displayed there. So we're just passing that user model onto the view, and then it knows how to display that. It knows how to hydrate itself once it receives that data. So I think this sort of approach has some definite advantages, especially when it comes time to test. And so in order to write tests for our non-Android half of the application, we can just have a simple presenter test written in JUnit that sends some inputs into our presenter and then senses the results. Same thing with the model test. And the whole time this is facilitated by this fake implementation we have of our controller interface, which then is going to receive those callbacks from the presenter, and that's where we're going to verify the results. When it comes to testing the half of our application that actually knows about Android, or hopefully it's less than half, but the other side of it, then that's where something like Espresso can come into play, and this time you're running your full stack end-to-end and testing how it behaves as the input is driven through the user interface and goes all the way down through your stack, and then make sure the correct result is actually synchronized to the screen state. So I think it's helpful to take a step back sometimes and think about why we're applying these principles, why we're doing these patterns. I'm not claiming that this one is one size fits all. Actually, there are still some challenges here that we haven't addressed yet. In particular, there are some very unique Android-y challenges that come up when you're building any sort of application, even if you have a very clean approach to laying out your code. One is, how do we handle the idea of that our app may be in the foreground or maybe in the background at any given time? How do we scope the presenter? Do we scope it to the life cycle of the activity? Does it die and get recreated just like the activity on configuration changes? Or does it persist? Where do we cache data? Keep it in memory. Same thing with view state. And then finally, how do we keep an eye on long-running operations? So if we start something in one instance and then we rotate, we get the behavior expected when it comes back. And so this is where Android architecture components, I think, comes in and plays an important and vital role in our efforts as a community to implement these types of patterns and improve our lives as developers. I have to say, when Android Architecture Components was announced at Google I/O this year, this is the second most excited I have ever been for an announcement at Google I/O. The first time was when we found out that we were losing support for Eclipse and moving to IntelliJ. And I also really like the honeycomb throwback theme. All right. So I'm not going to go through what each of these components does. At this point, there's been a number of talks of them at this conference, and they've been out for a number of months now, and so you're likely familiar with the basic idea of the different components that are available, and actually there's even more than this now. But we're going to look at these four and how we might apply them to our already existing clean app design in order to tackle some of these specific challenges that have come up. And so just as a quick recap, Lifecycle introduces the ideas of lifecycle owners and observers, as well as events and states. ViewModel is all about helping you maintain your state of your app on configuration change. LiveData is the observable wrapper class for your data models that is also lifecycle aware. And then finally, Room is the SQLite abstraction layer. So looking at Lifecycle, well, how can we start to implement this in our existing clean code base? Well, the first step is easy. We just make our activity extend lifecycle activity. And in fact, as of with the release of the beta version in the stable API, this isn't even necessary anymore, as app-compat activity has the lifecycle awareness now built into it now that the API has stabilized. But then there's one further step I like to take here, and that is I actually have my view interface or my controller interface that is seen by the presenter extend from the lifecycle owner interface. And this is going to come into play later when we want our non-Android portions of our app to know about the lifecycle, but not to know about the Android framework. Okay, well, that was easy, but it isn't actually solving any of our problems yet. So let's look at ViewModel. And now, as we think about the idea of ViewModel, there's actually two versions of ViewModel. There's the regular ViewModels, and then there's the Android ViewModel, which gives you access to context. I want to be clear about this. Buyer beware with the Android ViewModel, because right away, if you use that, you're introducing an Android dependency framework, Android framework dependency into the non-Android half, and that's going to have implications for the testability and also the maintainability of those components. And so, unless you have a really good reason to use Android ViewModel, I would say default to using the non-Android version of the ViewModel with architecture components. So we need to implement a new class that extends ViewModel, and we're going to use this to actually hold on to our user data once the user has completed logging in. And so what does this do for us? Well, now when we start up our activity, you can see we're basically doing what we were before, but we have this additional step of getting a reference to this activity's ViewModel. Now, the activity has to be the one who performs this step by nature of the fact that the lifecycle of the ViewModel is tied to the overall lifecycle of the activity. It persists through the configuration changes, but it needs to know how to clean itself up once the activity is finally finished for good. But we don't really want the logic of our ViewModel to live in the activity, so what do? We pass it over to the presenter. One question you might ask at this point is, can't we just replace the presenter with a ViewModel? Well, you could, and this might be just fine for a more simple application, but for me, I like to think of the presenter as the logic that is deciding what to display and how to display it, and the ViewModel is what actually maintains the state. And then what this allows us to do is we can scope the presenter to the life cycle of the activity. It can be destroyed and recreated on every configuration change, and we only put what we want to persist into the ViewModel. And so we modified our constructor for the presenter, so now it knows about the ViewModel. And so what does it do? When it starts up, it itself checks to see if we already have a user. And so imagine that we just recovered from a configuration change, or the activity got blown up, and we're coming back in now. We don't want to force the user to log in again. We want to say, oh, if we already have a user that's authenticated, let's just display that one. And so that's the check we do in the initialization block here for the login presenter. And then now, and we also, oh, I'm getting ahead of myself. Right, we're not registering any observers yet. That comes in the LiveData part. The only other thing we're doing is once we successfully authenticate a user, we store that away in the ViewModel. Which then brings us to LiveData. And so this is the lifecycle aware wrapper for your model classes. And so what LiveData allows us to do is actually wrap up that user instance that lives inside of the ViewModel with this observable interface. So now the presenter is going to look a little bit different. Instead of pushing those updates to the view in the same way with more of a manual process of checking and then calling the method through the controller interface, it's actually going to set up the controller to observe those changes in the view model. Again, so here we get all the benefits of the view or the controller observing the changes in our data model without the presenter having to know anything about the fact that that's an Android class behind that controller interface. And that's why we originally had the login controller interface extend lifecycle owner, so that it can then be registered here as an observer on the LiveData. And now there's just a little bit of extra care needed when we set the user value that we successfully fetch onto the LiveData instance. We're setting it on the value of it as opposed to just the raw field of user. And then finally, the last component here that I wanted to mention is Room. We're not going to do a deep dive on Room. Actually, there's a talk happening about it right now, which you're missing, so go back and watch the video if you want more details. But just as a brief overview, it allows us to map our data models directly to our database. And so we can do things like have a local storage that persists copies of our user data so that we don't have to fetch it over the network each time. And then through the data access object, we can actually convince Room to return us LiveData instances of our data model, which is then really nice because we can just push that out to our view model and have that data persisted there. So there's the domain model object that actually performs login, and there's a lot of hand waving going on here because I didn't want to just kill you guys with lengthy code samples here. But ideally, you'd have some sort of repository pattern in place where it would first check the network, or rather first check if there was a local cache of the data in the database and then refresh it from the network. And that would all be abstracted away from the presentation layer. And so now what we can do is, knowing that we're going to have a long-running operation potentially to fetch our user, we can actually have that happen from the view model. And this will help us with maintaining the where an operation is started, a pre-configuration change, and then post-configuration change, we can register and get the result for that. And so here's the last time I'm going to show you the code for login presenter, but this actually has all the other pieces in place, which now we can just observe. We're actually making the request to get the user through the view model so that that long-running operation can continue to happen in the background through a configuration change, through a pause and resume. And then the updates will then come back to us only once the activity is in the foreground again. So here is a brightly colored diagram. Wow, that's really bright, isn't it? Of everything that you could potentially use in place using our original clean app design, but then one by one adding in these new tools that we have available through architecture components. So just to walk through the whole stack here, imagine we're back in login land. You have your user input here of the user entering their email and their password and then tapping on a button and saying, okay, I want to log in. Well, that event is then forwarded. The activity is listening for that click event on the login button, which then immediately forwards it onto the presenter, which it had previously created using its own view model instance that it fetched for itself in onCreate. The presenter then uses that view model in order to call out to the repository, which abstracts away the idea of the web service and the persistent storage on the client side, goes and fetches the data from either the database or over the network, and then wraps it up in that LiveData object, which then gets pushed back to your view model. Well, then your controller interface is looking for changes on the view model. Once it sees one, the update gets pushed back into the activity, and the view refreshes itself, and we have our state synchronized. Oh, and just for bonus points, it's really nice if you use some sort of dependency injection framework to put this all together. Definitely not a requirement. Constructor injection and field injection are valid forms of dependency injection. We don't necessarily have to use something like Dagger, although it can be really helpful as your app gets more complex. So if you're into this sort of stuff, I do have a sample project with some of these ideas implemented on GitHub. I also write occasionally about testing and clean architecture and other things like that on Medium. Don't let the URL Android Testing Daily throw you off. I started out very ambitiously on this project, but now I post more occasionally. So, to wrap up, I'd like to put out some thoughts and some ideas that I'm going to be paying attention to as we move forward in the new world of clean Android architecture. So the first one is, and I feel like this is worth noting, is that the idea of clean architecture on Android was really driven by the community. You know, when I did a search, a Google search as I was preparing for this talk, the first posts about clean architecture on Android only started to appear around 2014. And so it's rapidly evolved in that amount of time. But it's only this year that there was some sort of official support announced for it. And so in a lot of ways, I feel like the Architecture Components project has been an example of Google picking up what the community has been putting down for a number of years now. And it's great to have everybody working in the same direction. I really want to stress that these components are mix and match. So I purposely layered them in one at a time to show how they can each serve inside of an application design. Doesn't mean you have to use all four or however many more get introduced in every project. Each project's going to be unique, and you can just use the ones that actually solve your individual app's challenges. Everybody's favorite topic. I'm really curious to see what this project means for the future of fragments. The fact that it has full fragment support on one hand says, hey, this could be the resurgence of fragments where the community fully embraces them again because we were starting to move away. It could also mean that now that we have all these additional tools for managing lifecycle and maintaining view state, that we actually don't need them anymore, and new frameworks are going to emerge based on lifecycle and ViewModel and LiveData that completely cut fragments out of the picture. So it will be interesting to see what happens as we move forward now with this new set of tools. I'm also really excited for the idea of lifecycle-aware libraries. That kind of speaks to the last one, but not just for UI frameworks, but for a variety of implications, or even just the idea that you could have an SDK that automatically initializes itself when it senses that the app has just launched. And finally, I just want to say that these are all pretty new concepts. The fact that clean architecture has only been talked about in the Android community for 2 or 3 years now, compared to its long storied history, means that we still have a lot to learn. And we're all learning this together. So if you see anything here that you have an idea about how to maybe do it better, come talk to me afterwards. I'd love to hear about it. And I'm also excited to see what projects you all come up with. Thank you.